Okay, so today I'm talking about basic counting, permutations, and then 4.7 is combinations. So the first thing is called the fundamental counting principle, and this is just a method of counting total possible options. I did not give a big enough space for myself. Okay. So our first one says there's 4 different basic blood types, AB, A, B, and O. There's also an RH factor that's represented either by a plus or a minus, and if a local blood bank labels the donations according to type, RH factor, and then they also on top of that put the gender of the donor, we want to figure out how many different ways the blood sample can be labeled. So there's the 4 different blood types, there's the 2 different RH factors, and then there is the 2 genders, male and female. I multiply those all together and I get 16. So there are 16 different ways a blood bag can be labeled. Okay. When we are trying to decide if the same thing can repeat, it's important to know whether things can be, when we're finding a sequence, it's important to know whether things can be repeated or not. If they can be repeated, we don't have to worry about counting down. If they can't, then we start counting down. So number 2 says the letters A, B, C, D, and E are used in a 4-letter ID card. So there are 5 letters. Okay. We want to see how many different cards are possible if letters are allowed to be repeated. So there's 5 letters and the actual ID card ends up with 4. So I'm going to multiply 4 5s together. Okay. If I type this into my calculator, I get 625. So there's 625 possible combinations. It wants me to find how many cards are possible if each letter can only be used once. So I have 5 choices for my first letter. Then I have 4 choices for my second, 3 for my third, and 2 for my fourth. If I multiply that together, I've got 5 times 4, which is 20, times 3 is 60, times 2 is 120. Okay. The exclamation point is a symbol that has a special meaning in math. When it follows a number, it means you multiply all the numbers from that one down to 1. So, for example, if I had 5 with an exclamation point, I'd go 5 times 4 times 3 times 2 times 1. This symbol's name is factorial in math. Okay, and then it just shows you the pattern down there. So number 3 wants me to evaluate each expression. What I can do is, depending on the type of calculator I have, if I go in this one, I type 8 and then I go to math. I want to arrow over to probability and I choose choice 4 for the factorial symbol and then I press enter. It gives me 4320. I will send out instructions later on if you don't have a TI-83, 84 in the family right there. I'll send it out for if you have the scientific calculators. Okay. And B works the same way, so I want to do 12, and then I go math, arrow over to probability, choice 4, and then divided by 10, math, arrow over to probability, choice 4, which gives me 132. My next topic is a permutation. It's a set of objects in a specific order. So there is a photographer who wants to arrange 3 people, Carmen, Juan, and Christina, in a specific order for a portrait. I want to write down all the orders that these people can stand in for the portrait. So there's the one they list them in, Carmen, Juan, Christina. Then there's Carmen, Christina, Juan. Then there is Juan, Carmen, Christina. These are really hard to say together. Okay, then there's Juan, Christina, Carmen. Then there's Christina's then the last one to go first. Christina, 1, Carmen. And then Christina, Carmen, 1. And those are all the orders I can have the people in. Okay. So then there is a part B. It wants me to use the fundamental counting principle to find the number of possible orders and make sure it matches the answer to part A. So the way I do this is I do 3 times 2 times 1. I count down because there's a specific order to how they are being placed. So I just multiply. 3 times 2 is 6, times 1 is 6. Remember on the front side I had 6 total options of arranging the people, so 6 is my answer here. It wants me to do the same thing for 8 people. One thing I want to point out on on part B is this is the same thing as 3 factorial because that's 3 times 2 times 1. So if I want to do the same thing but I have 8 people, I need to do 8 factorial and then I type that into my calculator, which we did on the front side and got 4032 0. Okay. On number 5 is telling me there are 7 horses in a race and there's a large jackpot for anyone who can pick the finishing order of all 7. Because it's all 7 and order matters, I'm going to do 7 factorial. So then what I want to go do is on my calculator, I want to type in 7 factorial. So I go math. Oops, I don't know why I pressed enter twice. And I get 5040. Okay. For number 6, it wants me to find how many different ways a pledge class with 20 different members can choose the president, vice president, and Greek council representative. No pledge can hold 2 offices. So once they get a position, they can no longer be selected for a different position. There are president, vice president, and Greek council, so there are 3 positions. And there are 20 people. So what I want to do is I will count down from 20 until I've hit 3 numbers. So I have 20 times 19 times 18, and then I will type that into the calculator. And I get 6840. Oh, different ways. Okay. Then if I want to use a specific number in a specific order, but we're not choosing them all, we could also use this formula. So if it's a lot harder for me to count, I can use this. The calculators, some of them have this, some of them don't, so you can use either one on the calculator and it'll still give you the right answer. N is the total number of things you have, R is the number you want. So what you want to do is, in number 7, it tells me there's a lottery game with 40 numbered ping pong balls and they're put in a bin, 4 chosen at random, 1 at a time. To win the game, you need to match all 4 in the order they were drawn. We need to figure out how many different orders there are. So I would plug into this formula. 40 is my N, 4 is my R, so I have 40P4. Plugging into the formula, I get the 40 exclamation point over, I want to make sure this is in parentheses, 40 minus 4 exclamation point. I could type that into my calculator, or if I go back on here, in this calculator, I'll also send out the instructions for this too. If I go math, probability, I have an NPR choice. So I go to 2, I fill in. If it's older, it won't have the nice boxes. If it's newer like this one, it will. And then I press enter, and I get my answer, which is 2,193,360 different orders to win. Okay. Then there is another formula. So if I have multiple of the same object, but I'm counting down, I can use this. To use this formula is the n factorial over k factorial for the different kinds of k's. So the different kinds of k's in this example is looking at the letters of the word Mississippi. What you want to do here is we need to first count how many letters there are in the whole word Mississippi, and then I want to count how many of each letter. So Mississippi has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 total letters. Okay. There is one M. Then the next letter is I. It's 1, 2, 3, 4. S, there is 4. P, there is 2. Okay. Then what I want to do next, so the letters are my K's, and I want to plug in. So what I do is my N is the 11, and the K's are these letters. So I have 1 factorial times 4 factorial times 4 factorial times 2 factorial. So then what I wanted to do next is type this into the calculator. Math, probability. Then when I do my denominator, I want to make sure I do it in parentheses so I don't forget, because if I don't, the calculator will read it as multiplying in the wrong spot, so I want to be careful. Then I go back to math, probability, choice 4, 4, math, probability, choice 4, 4, math, probability, choice 4, and 2, math, probability, choice 4. And then close my parentheses, and then it gives me 34,650. So there are 34,650 different passwords that can be made from the letters in the word Mississippi. So for combinations, when objects are selected, it's when the order does not matter. Kind of think about it like a combination pizza. When you get all those toppings on there, it doesn't matter if you say sausages or bell peppers first. They're still going to end up putting it on the pizza. Okay, so number 1 wants me to list all the permutations and all the combinations of the four people living in the house. So it wants you to just pick 2 of them. So I'm going to use, I can use letters. R for Ruth, E for Elaine, A for Amma, and J for Jasmine. Okay, so I can have Ruth and Elaine. I can have Ruth and Amma, Ruth and Jasmine. I can have Elaine and then Ruth. I can have Elaine and Amma, Elaine and Jasmine, Amma and Ruth, Amma and Elaine, Amma and Jasmine. I can have Jasmine and Ruth. I can have Jasmine and Elaine, and Jasmine and Amma. Okay. So for combination, I guess I'm spelling out the word combinations. The order does not matter. So once I have a pair of people, I am done. So I have Ruth and Elaine, Ruth and Amma, Ruth, that should be an R, and Jasmine. I'm done with Ruth. Then I can have Elaine and Amma, and Elaine and Jasmine, and then I can have Amma and Jasmine. So notice I have 12 permutations and 6 combinations. It's not always half, by the way. Okay. So now we got to decide if it's a permutation or combination. So remember, combination, order doesn't matter. So it says from a class of 25 students, 5 are chosen to give a presentation. Now, it's telling me they're presenting, it doesn't tell me the order they're presenting in. So this one is a combination. Tells me a starting pitcher and a catcher are picked from a 12-person intramural softball team. Because I'm picking for specific positions, this one is a permutation. So number 3 is telling me a college instructor is giving a list of 7 projects to choose from, and each group has to choose to do 3 of the projects. A week into the course, the group has to submit the list of the projects they're choosing and the order they plan to do those projects in. So my first one wants me to use permutations. Remember, that's 7p3. So if I go on my calculator, I go 7 math probability NPR 3, which gives me 210. Okay. Then it says, midway through the first week, the instructor decides that the groups don't need to provide him to the order. What would we want to divide our answer from to account for this? So, if order doesn't matter, we would do 3 factorial, because there are 3 projects in order. So this is why on number 1, we divided by 2. That's not the word order. We divided by 2 on number 1 to go from permutations to combinations because we were selecting 2 people, and 2 factorial is 2. So C wants us to write a formula for the number of combinations of n objects taken r at a time. So we know it's NPR, and then we did divided by our factorial, which was r. Okay. So on the back, we have the combination rule. And this states that the number of combinations of n objects taken r at a time without replacement is denoted by NCR, and it's given by this formula. So you can either type in if your calculator has the combinations, or use the last formula if it doesn't. Okay. Number 4 says that while he is studying abroad, Tran is required to visit 10 different cities. He plans to visit 3 over the 10 over a long weekend. He doesn't care what order he's visiting them in. He doesn't care about distance. Okay. So to do this, what we want to do is we are just going to do 10C3. So then I go onto my calculator, I do 10, I go math, I go to probability, choose the C option this time, and then I type in 3, which gives me 120 different combinations of cities. Okay. Number 5 is telling me that at a school, a student government consists of 7 women and 5 men. How many different committees can be chosen with 3 women and 2 men? So what I'm going to do is I'm going to find each gender separately. Okay, so I'm going to start with women. There are 7 women, and 3 of them can be on the committee. So I'm going to do 7C3, which gives me 35. Then for the men, there are 5 of those, and 2 are going to be on this committee, so 5C2. Nope. Which gives me 10. Okay. Then what we do is we multiply the 2 results, because for each possibility of women, I could have 10 different combinations of men. So this would be 35 times 10, which gives me 350. Okay. Number 6 is kind of similar. It's raising money for a charity event, so a sorority selling a calendar full of tasteful pictures from some of the more attractive professors on campus. They need to choose 6 models from a pool of finalists that has 9 women and 6 men. We need to decide how many possible choices there are if they want at least 4 women. So we're going to have to figure it out for 4 women, 5 women, and then if the calendar has all 6 women, or 6 slots filled with women. So I am going to do 4 women, 2 men first. So the way I do that is I am going to do, there are 9 women, we're choosing 4. For the men, there are 6 of them, and we're choosing 2. So I can multiply my combinations together. So if I go 9C4, and then I can, oops, not in here. And I can times by, this one is 6 and 2. This one gives me 1890, or I could find those separately and then multiply, depending on how old my calculator is. Then I can have 5 women, 1 man, so that'd be 9C5 times 6C1, because we're choosing 1 man. Which gives me 756. And then there's the final option, oops, not 6 men, where there are 6 women chosen for the calendar. Okay. So then this would just be 9C6, because no men are being chosen, so we don't need to find the probability for men. Which gives me 84. Okay. Then for this one, we add our results. So when I'm finding multiple different combinations for 4, 5, and 6, I add my results. So I have 1890 plus 756 plus 84. Which gives me 2730. Possible combinations for how they could pick these people for the calendar.